Hydrogen chloride is a gaseous molecule, and when it dissolves in water, it's known as hydrochloric acid. Hydrochloric acid is an Arrhenius acid because when it dissolves, it increases the concentration of proton or hydronium. However, let's look at it in terms of a Bronsted-Lowry acid. So this molecular model shows the chloride ion bonded to the hydrogen ion. When hydrogen chloride dissolves in water, the hydrogen dissociates or pulls apart from this bond, but it doesn't take any electrons with it. And so a proton and a chloride separate. This proton attaches to water and forms hydronium, while the chloride is left all by itself. So to determine who is the proton donor and who is the proton acceptor, we've got to look from left to right. A proton acceptor must have hydrogen in its formula. So both hydrogen chloride and water have hydrogen. But if we look from left to right, on the left hydrogen chloride and the right chloride all by itself, we see that hydrogen chloride is what has lost its proton. Whatever loses a proton has one less hydrogen and its charge becomes more negative. Whoever gains a proton gets one more hydrogen in its formula and its charge becomes more positive. So hydrogen chloride is the proton donor. As we go from left to right, it loses its proton. Water, on the other hand, is the proton acceptor. As we go from left to right, it gains a proton. So hydrochloric acid is an Arrhenius acid and a Bronsted-Lowry acid, and water in this case is a Bronsted-Lowry base. Now let's look at ammonia reacting in water. Ammonia is an Arrhenius base because when it dissolves in water, it increases the concentration of hydroxide. Again, let's figure out who is the Bronsted-Lowry acid and who is the Bronsted-Lowry base. Bronsted-Lowry acid is a proton donor. Bronsted-Lowry base is a proton acceptor. As we look from left to right, the acceptor is going to have one more hydrogen in its formula and its charge is going to be more positive. So if I look at ammonia on the left with 3 hydrogens and no charge, and on the right we have a nitrogen and 4 hydrogens and a positive charge. Ammonia has gained a hydrogen or a proton, so it is the proton acceptor and it is the base. If I look at water, on the left hand side I have H2O and on the right hand side I have OH with a negative charge. Whoever donates the proton loses a hydrogen and its charge becomes more negative. So water goes from H2O to OH negative. It is the donor. It has lost its proton. So water can act as a Lewis base because it has lone pairs of electrons that can form a bond with a proton, and it can also act as a Lewis acid because one of its hydrogens can be clipped off as a proton and donated. It just depends on what substance is being dissolved in water, whether it will accept a proton or whether it will donate a proton.